So here are the warm-up problems for Chapter 3, Section 4, and it's the problems dealing with the rational zeros theorem. There's another video that's done to give you sort of an explanation of the thought process behind the rational zeros theorem. But if you recall, what we said is we take the factors of the constant term, and they refer to that as P, over the factors of the coefficient of the factors of the coefficient of the leading term, which in this case is a 1. And so in our problem, P is 3 and Q is 1. And so this one's pretty simple because we have few factors. So what do? We say it's going to be plus 1 times plus 3. It could be minus 1 times minus 3, and that pretty much takes care of 3, over what? Plus 1, minus 1, minus 1. So plus 1 times plus 3, minus 1 times minus 3, plus 1 times plus 1, etc. Now, what do you do then? Well, then you take these and you say, well, this could be plus 1 over plus 1, which would be 1. It could be minus 1 over plus 1, which would be minus 1. And now you realize you've kind of caught up here because a minus over a minus is plus 1, and plus 1 over minus 1 is minus 1. And the same logic is going to hold here. We're going to get minus 3 over minus 1, which is going to be plus 3. And then we're going to get plus 3 over minus 3, which is minus 3. So ultimately what we're going to say is it's plus or minus 1 or plus or minus 3 is going to be our answer. And so the answer to the first one should be answer choice A. And the first one, the answer choice is A. So that's right. You say, wait a minute, now what do you do with this? Well, remember now, these are the zeros. These are the values of the zeros. Now, let's just say, let's say we thought it was plus 1. What would we do? Well, we could use synthetic division and divide plus 1 into this. Oh, we're missing some things here. We're missing a fourth and a cubic. So a fourth cubic minus 4 squared plus 4 plus 3. And then what would I do? Well, I'd come down and I'd do my synthetic division and see if I can get a remainder of 0. And I have no idea if I will. But I don't know for sure that plus 1 is a value that makes this function equal to 0, but we can tell in a moment. Bring down the 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. Yep. Plus 1, minus 4 plus 1 is minus 3. Plus times this is what? Minus 3 plus 4 minus 3 is 1. And 1 times 1 is 1. And the remainder now is 4. So what do we conclude from that? Well, we conclude from that we tried plus 1, but it's not a value. It's not a value that's going to make this function equal to 0. And you say, well, I'm kind of getting impatient here with all this. So what if we just cut to the chase and let's put this in our graphing calculator and just see what we would get if we did that. And let me do a little clearing here. All I'm going to do is put in this as it's in the problem. X to the 5th minus 4x squared plus 4x. I'm not going to do this on all of them. I'm just trying to illustrate what the process here is. You graph. And you say, wow, it's an odd degree function, 5, and it's going to have opposite end behaviors. And son of a gun, it looks like maybe right here, it looks like maybe x equals minus 1. Quickly go to your table and see if x equals minus 1 makes it 0. Uh-oh, 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 uh-oh. This is one where, I don't know why they gave us this problem, but this is one where you can tell that the rational zeros theorem is not going to tell us what it is. Why? Because it's somewhere. What do you mean somewhere? The intermediate value theorem tells me that the value that makes this function equal to 0 is somewhere between 0 and minus 1. So maybe it's a fraction. But notice, since I have 3 over 1, I only get integer values out of this. So it didn't reveal to me any fractional values. So You stop and think about how you might do this one. This one would be a bit of a challenge. All right. They didn't ask us all that, but I just wanted to show you that while it's a helpful tool, it may not always produce the results you're looking for. So P here, 8. Q, that's minus 2. So Q is minus 2. So here we go again. Now what are we going to do? We're going to say, what are the factors of 8? Plus 1 plus 8. Minus 1 minus 8. Plus 2 plus 4 minus 2 minus 4. Over the factors of minus 2. Whew. Plus 1 minus 2. Not too bad. Minus 1 plus 2. And that's about it, isn't it? In other words, I can go the other way, but I think I got everything. So what do I do now? I now got to build this relationship. So you got to stop and think about this for a second. So I'm going to have plus or minus 1. That's going to be 1 over 1, right? And then I'm going to have plus or minus 2, because that's going to be my plus or minus 2's all over 1. I'm going to have plus or minus 2, plus or minus 4, plus or minus 8. Well, you stop if I'm confusing you. I'm just going ahead and cutting to the chase. Plus 2 over plus 1. Yep, plus 2 over plus 1 is 2. Plus 2 over minus 1, minus 2. Okay. Plus 2 over 2, yep, 1, and so forth. Now, but wait, what about the fractions? We've got plus 1, plus or minus 1/2, right? Plus or minus 1/2. And then we're going to have plus or minus 2 again. And then we're going to have what? Plus or minus 4. Plus or minus 4. But we already had plus or minus 4. So what's the remaining list? What kind of order they got these things in? Okay, start with a fraction. So we got plus or minus 1/2, then 4, then 2, then 1, I guess. Nope, they go the other way. So plus or minus 1/2, then plus 1, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Not this. You don't have these fractions. This one does not include 8. Must be, the answer is number 2 must be B. Let's check the answer. That answer number 2 must be B, hopefully. And the answer to number 2 is in fact B. Very good. Ooh, find a rational zero and use it to find the rest of them. Now this is where we're going to do a little work. And the reason is P is minus 18. Q, well, that's too easy. Q is just 1. So this won't be too bad. Here are the combinations we got to work on. Now look, this is, the denominator is easy. It's plus or minus 1 times minus or plus 1, right? 1 times 1 is 1. So we didn't have much to do there. This one's harder. Look, it's going to be plus 1 minus 18. Since it's a negative back there, it can be a plus 1 times a minus 18. It can be a minus 1 times a plus 18. So where's this going? It's going to go plus or minus 2, plus or minus 9, plus or minus 3, plus or minus 6, right? So those are all the factors of 18. So what do I do now? Now I've got to take these and package them up and say, well, it could be plus or minus 1. It could be plus or minus 2. It could be plus or minus 3, plus or minus 6, etc., plus or minus 18. And at this point, we don't know. We just start trialing and erroring. Well, let's be optimistic. Why don't we try 1 first? Why don't we say that the value that makes it equal to 0 is plus 1? I'll put plus 1 into my synthetic division process. So I'm going to have a 1, 2, minus 9, minus 18. Bring it down. 1 times 1 is 1. 2 and 1 is 3. 1 times 3 is 3. Minus 9 and a plus 3 is minus 6. 1 times that is minus 6. Ooh, minus 24. Exclude that one. This could get to be time consuming. So let's try another one. I'll try minus 1. I don't have an indication, so it's going to be the same. 1, 2, minus 9, minus 18. Minus 1 times 1 is minus 1. That's 1. Minus 1 times 1 is minus 1. A minus 9 and a minus 1 is a minus 10. And that's a 10. And so that's minus 8. That didn't work. Okay, let's try 2. Let's just try plus 2. And here we go again. 1, 2, minus 9, minus 18. Bring it down. 2 times 1 is 2. 2 and 2 is 4. 2 times 4 is 8. Minus 9 and a plus 8 is minus 1. And that's minus 2. So that's not, what am I saying here? These are all remainders that are not 0. I'm looking for the one that's got a remainder of 0. Let's try minus 2. Hope I'm not losing you here. I'm just using that same tableau over here. So I got 1, 2, minus 9, minus 18. I'm running out of room. Hopefully this is it. I don't know. Bring down the 1. Minus 2 times 1 is minus 2. 2 minus 2 is 0. Oh, gosh. Minus 2 times 0 is 0. Oh, maybe I'm going to get lucky. Minus 9 and 0 is minus 9, and minus 2 times a minus 9 is a plus 18, and I get a remainder of 0, and son of a gun, minus 2 is one of the zeros. The factored form is x plus 2. Oh, and what's the quadratic that survived out of this? It was a cubic. This is my answer here. My quadratic was x squared minus 9. Oh, boy. So what do I know now? I now know that x plus 2 in factored form times x squared minus 9 will equal that. Well, I can factor this thing. Yep. Can you? Think about it. X minus 3, x plus 3. X times x is x squared, plus 3x minus 3x is no x. A minus times a plus is a minus 9. So, son of a gun, the answer is x plus 2 times x minus 3 times x plus 3 factored. And so what are the values of the zeros? You turn all of these into setting them equal to 0. So I'm going to get a minus 2, a minus 3, and a plus 3. So that's the set of x values. Minus 2, minus 3, and plus 3. They got them in this order. So they got minus 3, minus 3, minus 2, and plus 3. So the answer to 3 should be D. The answer to 3 is D. So rocking now. Let's see if the number 4 one is going to be any more of a challenge. Okay, so this one looks a little ugly. This one looks a little ugly. Why? Because they give me some answer choices here that are, this is going to be a complex number possibility if we had one. Now, I'm going to be, okay, let's use our brain a little bit. So look, what are the factors of 8 over 1? Look, so we know that it's going to be 1, 8, 2, 4, right? All over 1. Plus or minus all those. Now just look at the answer choices here. As far as the numbers that are in these answer choices, we either got minus 4 or 4. So I would not try with synthetic division 1 or 2 or 8 because it's not possible to have one of those answers. So I'm going to go with the 4s. What am I going to do first? Well, I'm going to first try minus 4. No reason for that. And I'm going to say 1, 2, minus 6, 8. Same old process. Bring it down. Minus 4 times 1 is minus 4. 2 minus 4 is minus 2. Minus times a minus, minus times a minus here is what? Plus 8. Am I getting lucky? I'm getting lucky. Let me do that again. Sometimes I can't. Minus times a minus is a plus. Minus 6 plus 8 is plus 2. Minus times a plus, yay, is a minus 8. And I get a remainder of 0. I got lucky. So what does that mean? It means that x equal minus 4 is a 0. And in factored form, it would be x plus 4. But I'm left with this thing. I'm now left with this. What thing is that? I'm left with x squared minus 2x plus 2. Okay. So can I factor this? I don't know. We'll try it. Ready? Let me come over here and see. So I need something times, that'll give me 2, right? So that's going to be 1 times 2 or 2 times 1. And I don't see any way to come back to this middle term. Think about that for a minute. Look, if I go like x plus 1 times x plus 2, that would give me x squared, but it would give me 3x. If I change my signs around, I'd have minus 3x. So guess what? Quadratic formula time. Why? Well, I can't figure any other way to find the values of x and make it equal to 0. So I'm going to use my quadratic formula now, which is going to be the values of x. I'm kind of working down here now on this bottom side. Can you see that? So it's going to be x is equal to minus b, okay, minus a minus 2, minus b as plus 2, start over here. X is equal to plus 2, I don't want to do that. X is equal to plus 2, plus or minus b squared, minus 2 squared is 4, minus what? 4 times 1 times 2 over 2a, which is 2 times 1, right? So where am I? Plus 2, plus or minus the square root of 4, minus 8. What is this going? All over 2 plus 2 plus or minus, what are we going to do here? Right, square root of minus 4 over 2. So what are we going to do now? Ready? We're going to have plus 2 plus or minus I times 2. What did I do? Square root of minus 1 is I, and the square root of 4 is 2, all over 2. And divide all this mess by 2, and I'm going to get 1 plus or minus I. And what was the other value that we found? We found that minus 4 was a value. So put it all together. Here's 1 plus or minus I down here out of the quadratic formula. So it's 1 plus I times 1 minus I times x minus 4. And so, I'm sorry, x plus 4, because the value we used was minus 4. So the values of the zeros are minus 4, 1 plus I, 1 minus I. So it's minus 4, 1 plus I, 1 minus I. It's minus 4. So the answer to 4 must be B. The answer to 4 must be B. And the answer to 4 is B. All right, so we'll knock out these other two in another video. I think this one's gone on long enough. So I hope I'm not running too fast here to lose you. I'm just kind of work through and just applying the technique and using the synthetic division, using what we've concluded about the rational zeros theorem, and also what we concluded about the factor theorem, where if we had a remainder of 0, we had a factor. So, and also down here we had to go back and use quadratic formula, because this quadratic that I got here is an answer. I couldn't factor it, and so the reason I couldn't is because it has some complex numbers as the x values. So I'm gonna stop this one here.